Hello class, welcome to lesson 6.4, which is all about elimination using multiplication. Okay, so we've talked about solving systems of equations by using graphing, we've used substitution, we've done elimination by addition and subtraction. Now today, we're using multiplication. So by the end of this lesson, you should be able to solve systems of equations by using elimination with multiplication, and you should be able to solve real-world problems involving systems of equations. So here is your key concept for this section. If you want to screenshot this and add it to your little collection, go for it. This is pretty similar to what we did yesterday. We're just adding one more step. And that step is to multiply at least one equation by a constant in order to result with the two equations that contain opposite terms. I know that seems a little bit confusing right now, but we're going to go through problems to show you exactly what that means. But notice that it says multiply at least one. So sometimes you will multiply both equations by a number, okay? So let's look at this. We have our first example, which we want to use elimination to solve. We have 6x minus 2y equals 10. We have 3x minus 7y equals negative 19. Okay, so yesterday we focused on adding and subtracting, and we always had, like this, if this is a 2, this was always a 2 yesterday. Well, now we're up to having 4 different numbers, or coefficients, with our variables. So what we have to do this time is first we have to get it so that we have at least one coefficient that is the same. One way to do that is if I want to get this 3x, if I want to turn that into a 6x, all I have to do is multiply it by 2, right? But I can't just multiply my 3x by 2. I have to multiply everything by 2. So what this ends up looking like is we have our 6x minus 2y equals 10 is going to stay just as it is. But then we're going to distribute that too. So 2 times 3x is 6x. 2 times the negative 7y becomes negative 14y. And negative 19 times 2 becomes negative 38. Now if I look at my numbers, I have a positive 6x and a positive 6x. So now what I can do is subtract everything and see what I end up with. So I have a negative 2y minus a negative 14y. That becomes negative 2y plus 14y. So this becomes a positive 12y equals positive 10 minus a negative 38 becomes 10 plus 38. We end up with 48. And if we keep going, we end up with y equals 4. Okay? So I have one number. Now I just have to take that same number, plug it into either of my starting equations. So if I do 6x minus 2 times 4 equals 10. I have 6x minus 8 equals 10, or 6x equals 18 if I add 8 to both sides. X equals 3. My final step is going to be writing it just as an ordered pair. So my x value is 3, my y value is 4, and I am done with that problem. Now I have to go and try the next one on my own. I have 9r plus q equals 13, 3r plus 2q equals negative 4. Again, we have 4 different coefficients, so we have to multiply in order to get something. So I could either multiply and turn my 3r into a 9r, or I can multiply the top equation and turn my q into 2q. So what I'm going to do, I personally just like to change the bottom one, if possible. So I'm going to multiply by 3. And actually, I'm going to change it up a little bit because last time I had a positive 6x and a positive 6x. So I had to go through and subtract everything. I prefer when I get to add things. So I'm going to multiply everything by a negative 3 instead. So that means I am left with 9r plus q equals 13, and then minus 9r, because negative 3 times positive 3. Negative 3 times positive 2q becomes negative 6q equals a positive 12. Now all I have to do is add these numbers together. So my 9r's cancel. I'm left with negative 5q equals 25, where q equals negative 5. Once I divide both sides by that negative 5, then, just like before, I have to take that value and plug it into one of my starting equations. So if I do 9r minus 5, so I'm replacing my q with the negative 5, equals 13. I now have 9r equals 18, or r equals 2. Okay? Now I have the ordered pair. And sometimes it can be confusing as to what order you write your ordered pair in. But let's think about that. We always do x, y. I wonder if you guys remember or know why we always do x, y. It's because alphabetically, x comes before y. So then when you go to write other systems of equations with different variables, like r and q, you go and you write alphabetically which one comes first. So alphabet Q, R, S. Okay, so Q comes first. So Q is negative 5, and then R is 2. And that would be my ordered pair. Go ahead and try this one on your own, see how you do. Hopefully you said that the answer was 5-1. If you have any questions about that, please be sure to ask for some help. Our next example, we're still using elimination to solve systems of equations. But this time, we have 2x plus 5y equals negative 10 and 5x minus 3y equals 6. Unfortunately, there's not really a good number that I can multiply by. If I wanted to get my x's to be the same, I could multiply 2 by 2.5, but I don't like multiplying by decimals. So I know that's out. If I wanted to get my 3 up to 5, that would also be multiplying by a decimal. So I don't want to do that. Instead, I am going to, kind of like when you find a common denominator, you sometimes have to multiply the two denominators by itself. One option is to multiply. If I wanted to cancel my x's, I can multiply by 5 up here and by 2 down here. Okay, that'll give me 10x and 10x. So I'm going to change one of them to a negative so that way I can add it, because it'll be a positive 10x and a minus 10x. Now I'm going to go through and I'm going to rewrite my equation. So distributing my 5, I get 10x plus 25y equals negative 50. Don't forget you have to multiply all the way across the equal sign. And then negative 2 times 5x gives me a negative 10x plus 6y equals negative 12. Now if I just add those numbers together, 25y plus 6y gives me 31y. My x is canceled, sorry. And then equals negative 50 plus negative 12, negative 62, or y equals negative 2. My next step is going to be plugging y back into one of the original equations. So if I do 5x minus 3 times the negative 2 equals 6, I have 5x plus 6 equals 6, where I get 5x equals 0, so x has to equal 0. It's okay for x to equal 0. I know sometimes that throws people for a loop. But that's acceptable to have 0 as an answer. That does not mean that it is no solution. Remember, no solution comes when you have like a positive 1 equals a negative 1. It's when something just isn't true, okay? Let's try the next one. We have 6a plus 2b equals 2. We have 4a plus 3b equals 8. Okay, so I could multiply the top by 4 and the bottom by 6 and get my a's to cancel. Or I'm going to choose my smaller numbers, and I'm going to get my b's to cancel instead. So I'm going to multiply the top by 3. I'm going to, again, multiply the bottom by a negative 2. This way I end up with 18a plus 6b equals 6, and negative 8a minus 6b equals negative 16. From there I keep going. 18a minus 8a is 10a, or sorry, 18a plus, I'm adding, plus a negative 8a is 10a. 6b plus a negative 6b is 0. 6 plus a negative 16 is negative 10. So a equals negative 1. Then if I plug that value back into one of my original equations, I can solve for b. So I have negative 6 plus 2b equals 2, or 2b equals 8. b equals 4. So then I go back and I write my ordered pair in alphabetical order. A comes before B, so I have negative 1, 4. And that is my answer. Go ahead and try this one on your own, see how you guys do. Hopefully you said that the answer was 4, negative 1. If you have any questions about that, please be sure to reach out for some help. This will be our last example, okay? We're talking about a fishing boat that travels 10 miles downstream in 30 minutes. The return trip will take the boat 40 minutes. Find the rate in miles per hour that the boat in still water. Okay? So we have a few variables. I'm going to use B to represent my boat. Boat in still water. C is going to represent my current. And I'm talking about distance and time and rate, so I know I'm going to use my distance equals rate times time. Okay? So in this example, we're talking about going downstream, and we're talking about going upstream. Now, what information do I know about each? What is my rate? What is my time? And what is my distance? Those are 3 very important things that we need to know. So we need to figure out what all of these stand for. Well, we know a fishing boat travels 10 miles downstream, and then it travels back upstream. So that means both times your distance is going to be 10. What about the rate and the time? We know travels 10 miles downstream in 30 minutes. So that's a half hour. And the return trip will take 40 minutes. That is 2/3 of an hour, right? Now, if we think about it, going downstream, we have how fast the boat can actually go, plus the current, right? However fast a boat can go using its motor. And then whenever you're in a river, you're going to go even faster because you have the current working with you if you're going downstream. So we're going to say the rate is however fast it can go by itself, plus however fast the current is. Then to go upstream, we're going to go with however fast the boat is, but then you have to subtract off how fast the current is because you're going to be going against it. So what this means is our 2 equations end up being, we have our distance equals rate times time. So we have 1/2 B plus 1/2 C equals 10, because I am distributing my rate times time. So this is the time, and then my rate was, here, I just want to show you what step I just combined. I had B plus C, and this was my rate times, or my time times my rate. So I distributed that 1/2. That's how I got 1/2 B plus 1/2 C. And then, taking that same concept, I have the B minus C with the 2/3. So 2/3 B minus 2/3 C equals 10. Now, just like before, we've been practicing today, we have 4 different variables, okay, or coefficients. So what we need to do is get some similar coefficients by multiplying the equations. So in order to get a common coefficient, I'm going to multiply the top by 2/3. I'm going to multiply the bottom equation by 1/2. So if I do that, I end up with 2/6b plus 2/6c equals 20/3. And I have 2/6b minus 2/6c equals 5. Okay? Because 1/2 times 10 will give us 5 instead. So those are my 2 equations now. I can add them together. Or actually, yeah, I can add them together because right here I have 2/6, a positive, and in the second equation, a negative 2/6. So I can add my b's and I get 4/6b equals, okay, and I have 20/3 plus 5, which if you think about it, 5 is 15/3. So that is 35/3 equals 4/6b. And if I want to get b by itself, all I have to do is multiply by 6/4. Okay, so if I do that, I have 70/4 equals b, which 70 divided by 4 is about 17.5 miles per hour. So we have b, which, let's go back and look, what does b represent? The boat in still water. And we wanted to find the rate in miles per hour that the boat will be in still water. So that is 17.5 miles per hour. And I don't even have to go back and find out how fast the current is. If I wanted to, I could. The question is not asking for it. Okay? So why don't you guys go ahead and try this very last problem on your own, see how you do. Hopefully you determined that the speed is 105 miles per hour. If you have any questions about that, be sure to ask for some help. I hope you guys have a great day.